Welcome to CEC Gurukul Lectures. In this part of my series, I would be giving you some samples of PEOs, that is the Program Educational Outcomes for the students. Now PEO 1, the graduate will compete on a global platform to pursue their professional career in electrical engineering and allied disciplines. PEO 2, the graduates will pursue the higher education or engage in continuous upgradation of their professional skills. PEO 3, the graduate will communicate effectively and will demonstrate the professional behavior while working in diverse teams. PEO 4, the graduate will demonstrate the concern for society and environment. Now let me give you some other sample of a civil engineering so as to make you understand better about PEOs. The PEO 1, as far as the civil engineering is concerned, is to practice the civil engineering in construction, industry, public sector, undertaking as an entrepreneur for the successful professional career. Now PEO 2, in case of civil engineering, is to pursue a higher education for the professional development. PEO 3, exhibit leadership qualities with demonstrable attributes in lifelong learning to contribute to the societal needs. Now, coming on to the processes for PEOs, that is what particular process is being followed when the PEOs are framed. 1. The feedback format for collecting the data from the stakeholders. 2. A process by which PEOs are created and reviewed periodically. 3rd, a process to evaluate to what extent PEOs are attained, and a review, that is a mid-correction and continuous quality improvement. Now coming on to a very important part of today's lecture is a program outcomes. The program outcomes are the statements about the knowledge, skills, attitude, that is the attributes the graduate of a formal engineering program should have. We are taking here the example of an engineering program to make the concept simple. Now, the profile of all graduate reached through the program outcomes are the targets. So, PEOs are defined by the accreditation agencies of the country. In India, we have the National Board of Accreditation. So, defining the starting point of the program outcomes. Now, first is the engineering knowledge, that is the PEOs. The first is the knowledge, that is apply the knowledge of the mathematics, science, engineering fundamentals and an engineering specialization to the solution of complex engineering problems. Next is your problem analysis. Here it is to identify, formulate, review the research literature and analyze the complex engineering problems and reaching the sustained conclusions using the first principle of mathematics, natural science and the engineering science. Next is your design development of solutions. Design solutions for complex engineering programs and design systems components or the process that meet the specified need with appropriate consideration for the public health and the safety and the cultural, societal and environmental considerations. The next is to conduct investigations of the complex problems. Use research-based knowledge and the research methods including design of experiments, analysis, interpretation of the data, synthesis of the information to provide the valid conclusions. Now, the modern tool usage, that is to create, select, apply the appropriate techniques, resources and the modern engineering and IT tools including the prediction and modeling to complex engineering activities with an understanding of the limitation. Next is the engineer and the society, that is apply the reasoning informed by the contextual knowledge to assess societal health, safety, legal, cultural issues and the consequent responsibilities relevant to the professional engineering practice. Next is the environment and sustainability, that is to understand the impact of the professional engineer solutions in societal and environmental context, and to demonstrate the knowledge of and the need for sustainable development. The next is your ethics, that is, apply ethical principles and to commit the professional ethics and the responsibilities and the norms of the engineering practice. Next is your individual and the teamwork, the function effectively as an individual and as a member or a leader in diverse teams and in multidisciplinary settings. Next is your communication, to communicate effectively on complex engineering activities with engineering community and with the society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations and give and receive the clear instructions. Then we have a project management and finance, that is to demonstrate the knowledge and understanding of the engineering management principles and to apply this to one's own work, and this is the highest level of creativity as a member and the leader in a team to manage the projects in a multidisciplinary environment. Next is to have a lifelong learning, that is to recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the broadcast context of the technological change. Now coming on to the particular program specific outcomes. So every program outcomes are general and the program specific outcomes are very specific to that program. If you are doing the electrical engineering, you will have the electrical specific programs. If you are doing a civil engineering, we will have a civil engineering specific program outcomes. So just let us have a look on this. Now when you talk about the program specific outcomes of any program, these outcomes are very specific to a program in addition to the NBA defined program outcomes, namely civil, mechanical, chemical, computer science, etc. So let me give you some examples. The civil engineering can have a specific program outcomes as PSO1, that is, you are able to analyze and design building the structural system, because here we are talking about a civil engineer and he will be talking about the structural system. So it is very specific program outcome of the civil engineering program, that is, he is able to analyze and make a building, design, structure, etc. The specific program outcome as far as the civil engineer is concerned, number 2 is he is able to provide the design solution to the water supply and the sewable systems. Then we have the program specific outcome for the civil engineering, number 3, that is, he is able to identify and analyze the transportation engineering programs and provide the solutions for the benefit of a society. Now coming on to why the National Board of Accreditation program outcomes are what they are. So the Washington Accords graduate attributes and the NBA program outcomes we have to see in one line. Now coming on to the Washington Accord attributes and the NBA program outcomes. The first is the engineering knowledge, apply the knowledge of mathematics, science, engineering fundamentals, engineering specialization to the solution of a complex engineering problems, and the NBA program outcomes is the engineering knowledge, apply the knowledge of mathematics, science, engineering fundamentals and engineering specialization to a complex problems. Now coming on to number 2, that is the problem analysis. The graduate is able to identify, formulate, research literature, analyze complex engineering problems, research substantified conclusions and the first principles of mathematics, natural science and the engineering science. Now coming on to the attainment part of program outcomes of 1 to 5, which we have just read. The first program outcome, number 1, is engineering knowledge, that is, apply the knowledge of mathematics, science, engineering fundamentals and engineering specialization to the solution of complex engineering problems. Now the program outcome number 2 is the problem analysis, that is to identify, review literature, analyze complex problems, reach a substantiated conclusions using the first principle of mathematics, natural science and the engineering science. The program outcome number 3 is design and development of the solutions, that is the design solutions for complex engineering problem and design the system components, the process to meet the specifications with considerations for the public health, safety, cultural, societal and environmental considerations. Now basically the next aspect is to conduct the investigations of the complex problems, that is use research based knowledge and the research method including the design of experiments, analysis and interpretation of the data and the synthesis of the information to provide the valid conclusions. Now moving on to the modern tool usage, that is to create, select, apply appropriate techniques, resources and the modern engineering and IT tools including the prediction and modeling to complex engineering activities with the understanding of the limitations also. So why we place these program objectives in one basket? The statements show that one part of that complex engineering, the complex engineering problem is common to all, although individually reach the program outcomes deal with the different aspect of this, recognizing this commonality. So it makes the discussion very easier. So the complex engineering problem, that is the CEP, the problems not the kind generally encountered at the end of the textbook or the chapters. These often test if the content of the chapters have been understood, and these are the problems that not have been complex framed and leave at least a few choices for the students to make. So the problems may require the use of the laws of the physics or bring in some mathematical tools in which the problem can be framed. So now let us move on to the course outcomes, that is the CEOs. The statements of observable student action that serve as the evidence of KSA, that is knowledge, skills and the attitudes which are acquired in a particular course. Each course is designed to meet about 6 course outcomes, whereas the program outcomes, when you talk about under the NBA framework, is that they are given the 12 program outcomes, and they institutional level we make the program specific outcomes, but under the program outcomes there are 12 program outcomes and about 6 course outcomes which are to be definitely met as far as the NBA accreditation part is concerned. The course outcomes are stated in such a way that they can be actually measured. So that means when you are framing the course outcomes, they should be smart, crisp and measurable. The program outcomes are attained through the program specific core courses, and the courses outcomes are, for example, the engineering physics. It is the course outcome which I am explaining you, it is not a good example. Again, I will give you the corrected example also to make you understand better the corrected course outcomes. So here is the example of not a good example of the particular course outcomes of an engineering physics. So the first is understand the knowledge of the basic quantum mechanics to set up the one-dimensional wave equations and its application to a few physics problem. Now coming on to the second course outcome, that is to understand the fundamental aspects of the crystallography about to recognize the various plans or in a crystal and to understand the structure of the determination using the X-rays. Now coming on to CO3, that is to understand the role of free electrons in determining the properties of the metal, the concept of a Fermi energy and the domain formation in a ferromagnetic material. Now coming on to the course outcome number 4, that is to understand the basic laser physics, working of the lasers, holography and the principle of the propagation of the light in the optical fibers, and CO5 is to understand the theory of free damped and the forced vibrations of a particle, and also the concept of resonance and its application in ESR and NMR, that is what level of Bloom's taxonomy you want your students to achieve. that is from basic remembering level to understanding level to application level to analysis level to evaluate and to create. So, what kind of Bloom's taxonomy you want your students to achieve will be completely reflected in the course outcomes. So, this is in front of you, the Bloom's revised taxonomy, owing to which the module outcomes, that is the complete student learning outcome framework, is built, because we use the action words and we frame the student learning objectives, be it a module objective, chapter objective outcomes, or the course outcomes, the program outcomes, the program specific outcomes, the program educational outcomes, and the institutional vision and mission statements. So, everything is framed under a Bloom's revised taxonomy framework, and there are some people who are still using the old Bloom's taxonomy, but the concept remains the same, that is you are able to raise the level of the thinking level of the students right from the low level to the highest level, that is the creativity. That is the questions are formed, the outcomes are formed in terms of the remembering, that recall information and the understanding, application, analyzing, evaluating and the creativity. So, these aspects have to be kept in mind when you are using the Bloom's revised taxonomy. So, let me now give you the concept in terms of a comparison. If you see on the left hand side, there is a Bloom's level, that is K1 is to remember. The program outcomes are reflected using the Bloom's taxonomy. The K2, that is the level 2, is the understanding level, and the number 3 is a K3 is the application level, that is when you are able to apply the knowledge. The engineering knowledge is about apply the knowledge of mathematics, science, engineering, fundamental and an engineering specialization to the solution of a complex engineering problems. Now, coming on to the Bloom's level again, K4, that is to analyze. The program outcomes is the problem analysis. So, you can see here that we are moving on from K1 to K4, which is very good for the students, because they are now on a higher thinking order level, which is the main focus of application of Bloom's taxonomy in the application of framing the program outcomes, the course outcomes and the students learning outcomes is concerned. So, here on the screen we can see the K4 level, that is to analyze, and it is on to a problem analysis. So, the problem analysis here is to identify, formulate, review research literature, analyze the complex engineering problems, and of course, the overall reaching substantiated conclusions using the first principle of mathematics, natural science and the engineering science. So, these aspects have to be kept in mind. So, now is the evaluation level, that is the K5, that is the design development solutions. Design solutions for complex engineering problems and design system components of the process that meet the specified needs with appropriate consideration for public health, safety and the cultural, societal and the environmental considerations. On to the structure of the course outcomes. The course outcome statements may be broken down in two components. So, let us see these two components. An action word that identifies the performance to be demonstrated, the learning statements that specifies the learning will be demonstrated in the performance. The examples of the good action words to be included in the course outcome statements is to compile, identify, create, plan, revise, analyze, design, select, utilize, apply, demonstrate, prepare, use, compute, discuss, predict, assess, compare, rate, critique, outline and evaluate. So, now if you see on this particular screen, the course title is the strength of the material, and let us see the course outcome example. At the end of the course, the student is able to apply the laws of physics, that is the Hooke's laws to compute different types of responses, that is the stress and the deformation in the given material, that is PO1. So, if you see, the action word which is used in this particular example is apply, and the types of responses, that is the stress and deformation which is used, is a learning statement. So, these program outcomes are shown here as a strength of the material, and these are the course outcomes using the action word and followed by the learning statements. Now, coming on to the second one, that is to analyze. Here the program outcomes is to analyze the elements for the different force systems to compute the design parameters, that is B1 and SF, that is the PO2, that is the program outcome number 2. The third is to design the compression elements using the engineering principles to resist any given loads, that is PO3. The next is to conduct the experiments to validate the physical behavior of the material components, that is PO4. And the next is to prepare the laboratory reports on the interpretation of the experiment results, that is P10. Now, if you see the assessment part, here we are on the assessment part, which is a very, very important part for the any kind of institution, because owing to the assessment part we would be doing the accreditation part of any institution. Now, the assessment is, the first is, it is one or more process that identify, collect, prepare data to evaluate the achievement of the course outcomes and the program outcomes. If you see on the horizontal side, they are the program outcomes and the program assessment tools are mentioned. So, when you talk about the program outcome assessment tools, there are assessment tools which are direct, there are program assessment tools which are indirect. So, let me first tell you about how do we do the assessment as far as the direct part is concerned. So, directly you can assess the outcomes or the attainment of the program outcomes by taking the test of the students, assignments of the students, and of course, the labs, the seminars, industrial training projects and the rubrics. So, if you are able to have that kind of an assessment, you can have a tick like first we are taking the test. So, you can see a tick from 1 to 4, and in case of the assignments you can see in all 4 program outcomes we are taking it. In the labs we are also taking it. So, these are the direct tools of assessment as far as the program outcomes attainment is concerned. Now, assessment, it is one or more process that will identify, collect and prepare the data to evaluate the achievements of the course outcomes and to prepare the program outcomes. So, when you talk about the program course assessment tool, here we are talking about the course end surveys, the exit surveys, the faculty surveys and the program statistics. So, when you talk about all these aspects, these are the indirect tools. So, these direct as well as indirect tools are used to understand the program outcomes attainment. Now let me give you the CO-PO relationship, that is what is the main relationship of the course outcomes and the program outcomes. Each course outcome can be identified to address a subset of POs. Based on the number of the course outcomes and the sessions dedicated to them, it is possible to identify the strength of mapping first, second and third of the POs. If you do the strength of mapping, 1 is low, 2 is moderate and 3 is superb. That means you are able to achieve the strength. So, if we move from 1 to 3, it shows the strength of the mapping of PO and COs. So, based on these strengths of the selected PO-CO matrix can be established. You can see here the PO-CO relationship is very, very clearly exhibited on the screen. On the left hand side is the course, the analysis of the structure, environmental engineering, geotechnical engineering, etc. So, whether mapping of the PO and the CO is there or not, we can see this matrix. So, if you see the first, we have shown number 3, that is the matrix of the analysis of the structure and the program outcomes of that particular course. So it is showing 3. 3 shows the strength, and if you see the second one, it is also showing the 3. That means we are able to achieve the PO-CO mapping, and it is a very, very strong mapping, because the 2 shows the moderate level, 1 shows the lowest level, and 3 shows the strength. So we can see here that as far as the PO-CO relationship is concerned, the analysis of the structures, the environmental engineering and the geotechnical engineering, we are able to have 3. That means the matrix is very, very good. Now let us see the other courses PO-CO relationship in this particular example. In case of the concrete technology, again it is 3. In hydro and the water resources, in the quantitative surveying and costing, it is the first outcome, it is showing 2, and in case of the PO-CO attainment of CO is showing as 2. So we can see this matrix, that what we are able to achieve, and this matrix is is very, very helpful in understanding the relationship of the POs and the COs. Now if you see the overall aspects of the PO-CO relationship, for the accreditation bodies, this PO-CO relationship is assessed in the depth, all the particular programs what you have, what attainment do they have, what kind of mapping do they have, is a very essential condition for the accreditation grades. So each course outcome can be identified to address a subset of the POs, which is very important, and as already been assessed and addressed in my lecture, that is based on the number of the COs and the PO sessions dedicated to them, it is possible to identify the strength of the mapping. And 1 shows the lowest strength, the 2 shows the moderate strength, and 3 shows the maximum and the best possible extent. So based on these strengths of the selected PO-CO matrix, the further steps of the strategies of the accreditation bodies and the percentage of the attainment will be taken up in the next sessions.